Welcome to the Stormsurf video surf forecast for the week starting Sunday, April 5th. Looking at significant wave heights for the North Pacific Ocean, we see one area, 20-foot seas off Kamchatka. Those seas mainly pushing towards the Aleutian Islands, maybe a little bit of clearance south of them, but not a whole lot going on. Another area, low pressure off the Pacific Northwest, not doing much, seas below 18 feet and of no real interest. We'll take this week's tour starting at the jet stream level winds. That is, winds up about 30,000 feet. These winds help support the formation of storms, and when those storms do form, help direct their track. Right now, we have a split jet stream flow. Not good, not supportive of storm development. That is, the southern branch is coming off of Asia, just basically tracking flat east over the Hawaiian Islands and into Baja, while the northern branch, a little bit more energetic, but is up, basically tracking over the Aleutian Islands, then finally dips south, just off the Pacific Northwest, forming a trough capable of supporting low-pressure development, but nothing more. The interesting thing here is a bit of energy is finally moving into California, perhaps ushering in some weather. Let's put this into motion. As we see, the pattern continues Monday, Tuesday. Another little bit of a trough tries to organize here in the Gulf on Tuesday, but for the most part, it's pinched off, not really doing a whole lot. At least there's a little bit of wind energy flowing into it. And over here, no troughs, everything's still mostly landlocked. We get into Thursday. Again, this sort of troughy pattern continues in the eastern Gulf and only holds that way into Saturday. And then finally, that trough pushes onshore on Sunday. Notice here the last frame, another little bit of a trough trying to develop. So what this all suggests is perhaps a series of short waves moving over California, good for maybe some precipitation on up into the Pacific Northwest. Any drop helps, but in terms of storm production or gale production or swell production, not a whole lot on the chart. Next, we'll take a look at surface level pressure, surface level winds. We see high pressure here in the western Gulf, high pressure also off of the Kuril Islands. This basically is a mirror of what's reflected in the upper atmosphere, that is the split jet stream. In between the two flows of the jet, you typically get high pressure. That's exactly what we're seeing. The storm track basically going up this way through the Bering Sea and then down into the eastern Gulf. But we see one area here, what is that, 30-knot winds, not of particular interest. That swell period less than 13 seconds, so it isn't even swell, it's wind swell. And as we saw in the earlier chart, 20-foot seas in this area, mainly from fetch developed earlier in the day. And then coming down the U.S. west coast here, winds 25 knots, not of real interest. Let's put this into motion. Roll this out. You see again, low pressure continues to develop Monday off the California coast. Sort of a front sets up, sweeping down the coast. More fetch trying to work its way into the Gulf on Tuesday, but just really doesn't do it. It kind of falls apart. More energy tracking through the Bering Sea, but again, the Aleutian Islands are right here blocking any swell energy from getting into the greater North Pacific. That pattern sort of continues. Again, more energy spilling into the eastern Gulf on Friday. Another small low pressure, but notice these winds are only 20, maybe 25 knots. That's not enough. Yeah, it'll make some wind swell, but nothing more than that. Wind swell is good. We'll take it. And rain, even better. Anyway, we roll this out, and so the low pressure pattern dissipates. We're 168 hours out, and the models suggest a low again off the Kuril Islands, likely bound for the Aleutians. In fact, we'll just put this into motion. That actually looks reasonably good, but again, 180 hours out, not believable at all. 50-knot winds this time of year, not believable, but it's something to look forward to, something to monitor. So next we'll go down to the surface here, take a look at significant wave heights. Again, the area of 20-foot seas off the Kuril Islands here, we'll just put this into motion. It quickly dissipates. Not even 18-foot seas lasting, pushing south of the Aleutians, on into the Gulf. Not a whole lot going on. Pretty quiet pattern. All the energy again, landlocked up north of the Bering Sea. Watch this pattern. Again, it follows the jet stream right up and over through the Bering Sea, down the U.S. West Coast. We're into Saturday of this week. This low pressure not doing anything, all this, no seas even hitting 18 feet until we get to the final frame here. This is that low pressure system we saw starting to get traction on the ocean surface. Notice the winds in the previous model are stronger than what the seas would think. That's because the wave models it takes about 6 hours for that wind to get traction on the ocean surface. Still, what do we have? 24-foot, 25-foot seas modeled. Guaranteed the next run of the model, this low won't even be there, or if it is, it'll be much weaker. So for now, the North Pacific looks like it's asleep. And now we'll take a look at the southern hemi. Same deal situation. Things fairly quiet right now. 22-foot seas would never make the journey up to California. This area here, good for maybe some swell along the Chile coast in Peru, but that's about it, and that fades out. We'll just roll this out. There's an interesting little low here that develops on Tuesday. That's about 38-foot seas forecast, 36 to 38 foot. Aimed reasonably well to the northeast. This could push sideband energy up into California from about, well, here we're on 120, so about 184 degrees or so. And then mainly, though, the focus here is Chile in this area and Peru. Nice little, very small system, though. Small footprint, but pushing well towards the coast. Anyway, we roll this out. Another series of systems are forecast under New Zealand. And we'll see whether this materializes. The first one here, this on Saturday, decent, what is that, 30, 32, 34, 30, maybe 5 or 6 foot seas, pushing up mainly towards Fiji and certainly towards New Zealand. Also another little system here, but they're so tiny. This is much better. It covers a much larger area. You get much better energy propagation. Again, this looks like a Fiji system, and then but once it gets below New Zealand, let's see what it does, and that's the end of it. So it's hard to say. It would be interesting to see if this low actually tries to redevelop and get some traction over in here. Something to watch for a week out. But because it is 180 hours out, we don't believe anything's going to happen from it. Let's go take a look at long-term predictors. First up, the Southern Oscillation Index. Difference in pressure between Darwin, Australia, and Tahiti. Positive numbers represent the inactive phase of the Madden-Julian oscillation and do not support the formation of El Nino. Negative numbers represent the active phase of the MJO if they go for a decent amount of time, and also potentially represent the development of El Nino. Right now, we are coming out of the active phase of the MJO. It was very active in early March. The bottom has basically fallen out now. It's sort of hovering around neutral, slightly positive. The 30-day running average, still pretty solid, minus 10.72. That would definitely still be the hangover from the previous active phase of the MJO. Long-term 90-day running average, minus 6.45. It's been in this range, between this and about minus 8 since mid-October. No change forecast. A very weak form of El Nino is what this suggests. Next, we take a look at wind anomalies. That is, differences in wind direction and speed for this location of the planet compared to this time of year. Currently, we have still more westerly anomalies. That is, trades in this area are normally out of the east. They are slack. If anything, there's almost a reversal of trades. This has been going on for months now, but particularly strong in the month of March. A very strong westerly wind burst. That is, very strong, not only westerly anomalies, but literally westerly winds occurred and helped support Kelvin wave development. We'll get into that in a minute. But right now, that pattern associated with the active phase of the MJO appears to be backing off. And if in fact, we're actually in the inactive phase of the MJO in this region, yet we still have westerly anomalies. This is a good sign. This suggests that the atmosphere has made a turn from years previous, and that the tendency now is towards supporting the active phase of the MJO and towards supporting El Nino. We'll see if that holds up. But anyway, currently, westerly anomalies in place to the date line. This is the Philippines here, Australia here. We'll move off to the east now. Here we go. There's Hawaii there. And light easterly anomalies on the equator, and that's all we care about, a couple degrees either side of the equator. That's where the pattern is. And then basically neutral into the Galapagos. And interestingly enough, even though a week from now we're still supposed to be the inactive phase, Westerly anomalies are forecast to continue, not over a large area, but is this area right here from about 135 to about 170 that's the core of what we call the Kelvin wave generation area. That is, westerly anomalies in this area, slackening of trades, if not out and out west winds, will cause warm water that traditionally is in this area to start falling to depth, create a thing called a Kelvin wave, which is a pocket of warmer than normal water, that then will traverse the entire width of the Pacific and gurgle up off the Galapagos 3 months later. The warming of waters off the Galapagos Islands is the hallmark of El Nino. So currently the machine is in play to try to support the formation of El Nino, and theoretically, according to NOAA, we're in El Nino, but it's such a weak El Nino, and given the time of year, it really has no influence on the atmosphere at this point in time. Anyway, looking also off to the east, here we are, Hawaii again, Mexico, pretty much a dead neutral pattern either side of the equator, just a couple of degrees, maybe a little bit of westerly anomalies here south of Hawaii, but really nothing of any particular interest. Here is the historical chart. This is the wind anomalies over the entire globe for the past month or so. The area we're interested in is the Pacific Ocean, which goes from about here to about here, roughly. Okay, oranges and yellows are westerly anomalies. Okay, the interesting part here is early March, strong westerly anomalies, the reds, oranges, purples, and then that westerly wind burst faded out about mid-March, but still westerly anomalies continued, and still to this day are still present there, as we've seen in the previous charts, and are forecast to continue. This is a long run of westerly anomalies, good to support Kelvin wave development. Next, we look at outgoing long wave radiation models. The current image, the oranges and yellows, are the inactive phase of the MJO, typically representing easterly anomalies, more sunlight reflection off the ocean surface and high pressure, whereas the blues are the active phase of the MJO, more cloud cover, less sunlight reflection off the ocean surface, and representing the active phase of the MJO. Currently, we see the inactive phase supposedly in play, but we know for a fact there are westerly anomalies at the ocean surface here. Good sign. Anyway, so the inactive phase, per the statistic model, is supposed to hold but slowly weaken over the next 15 days, while the active phase holds together reasonably and tries to push to the west. Actually, that was to the east. Anyway, the dynamic model, a different model, says the inactive phase is to slowly fade, fall apart, then redevelop back to the west and move back into the Pacific, while the active phase just dissipates completely. In other words, the two models are in complete disagreement from one another, and who knows what's going to happen. The upper level model, this is at the jet stream level, so this shows areas of supportive of precipitation, which presumably is associated with the active phase of the MJO, the greens and the greens, that is. So supposedly, a weak version of the active phase of the MJO is occurring over the dateline region and working its way to the east over through April 25th, and at that point in time, a inactive phase is developed in the west and then make its cycle the whole way across the Pacific through about the middle of May. So, much ambiguity between the models, no consensus. The suspicion is we'll end up with some weak sort of pattern with no real coherence one way or the other. That is the sign of El Nino. Next, we take a look at sea surface temperature anomalies. It is the warming of the ocean surface that is the true hallmark of El Nino. The winds blowing are the mechanisms, or wind deviations that we've seen are the mechanism to create the warm water, but it is ultimately warm water, specifically in this region right here, in this sort of a pattern that is the hallmark signal of El Nino. And interesting about this image, we do have warm water building here near the Galapagos and the whole way along the Peruvian coast and Chile. That has not happened to any extent in the past year. And so this leads us to believe that maybe the El Nino that tried to get going in 2014, we'll call it a false start El Nino, is actually maybe getting some traction now. And maybe the atmosphere is starting to become more favorable. Anyway, we have warm water in the region, not great warm water, but given the time of year, this is actually a pretty good start. Warm water, of course, along the whole U.S. West Coast, though we have seen water temperatures drop dramatically in the San Francisco area due to north winds, typical for this time of year. In fact, we almost were beginning to think they were going to fade completely, but they're up now. You know, strong north winds, water temperatures 52, 53, which is not unusual, still normal, and for the most part, only limited to an immediate area right along the coast. Anyway, warm water also here, present on the date line. This normal patch of cooler water, at least it's been normal for the past couple of years, but still notice it's not getting to the equator, a couple of degrees south of the equator. So all in all, a pretty favorable looking pattern. And another way to view that, based on the TAO buoy array, hard data from the surface, buoys, not satellite measure, but actual buoys on the ground, and measuring not only water temperatures, but wind speeds and directions. Here's actual wind speeds and directions and water temperatures. Notice a little arrow here, actual westerly, not westerly anomalies, west winds, but if nothing else, dead winds in this, the Kelvin wave generation area. Again, from about 135 to about, well, let's say the date line, roughly a couple degrees either side of the equator. But interesting, as you get down on the surface here and look at anomalies, full-on westerly anomalies still in play the whole way almost to a point south of Hawaii. Water temperatures a half a degree or warmer all along the equator with a pocket of 1 degree anomalies here and 1.5 to if not 2 degree anomalies here. We're right in the area where westerly anomalies are blowing or westerly winds are occurring. That pushes that warm water to depth, helping to form a Kelvin wave. And now the ultimate indicator, subsurface water temperatures, West Pacific here, East Pacific here. Here are the TAO buoys and their anchor lines with sensors on the anchor lines. This is actual water temperatures, but it's not in depth down to, let's say, 300 meters. But you know what? It's not the actual water temperatures. It's the deviation from normal for this time of year for this location. And notice this, 4 degree, 5 degree anomalies. This is a Kelvin wave. So we'll paint the picture one more time. Westerly winds or a slackening of trades in this area in the far West Pacific allow warm water that's normally here to start falling to depth. It creates this pocket called a Kelvin wave. That Kelvin wave starts migrating to the east and then creates the warm waters off the Galapagos Islands, which is the hallmark of El Nino. This is a solid Kelvin wave, a very strong one created by very strong westerly anomalies, if not 25 knot west winds that occurred in early March in this area. So just for comparison, last year at this time, we had a massive Kelvin wave. We thought we were going to get a very strong El Nino from it. Here is the subsurface water temperature anomalies, 3, 4 to 5 degrees. Another pocket at this time working its way into the Galapagos. Here is the current situation, looking very similar. Again, another pocket. This pocket isn't quite as strong. This one looks every bit as strong. So basically, a repeat of last year's westerly wind burst event and Kelvin wave event occurring 2 years in a row. Very unusual. Anyway, here's another depiction of the current Kelvin wave. This from data from March 29th. What is that? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. This one suggests 5 to 6 degrees. You can see a little pocket there of 6 degree anomalies. This is maybe a little bit hyped here, or the other one maybe is a little bit on the conservative side. Either way, Kelvin wave in flight, major warming expected for the Galapagos Islands. So that's the good news. It'll take it another 2 months. We're looking at May to June before this Kelvin wave fully erupts along the coast of the Galapagos. The question is, will we get another westerly wind burst, or will everything sort of fall apart? Last year, that's what happened. We had a giant Kelvin wave. It hit. We got lots of warming. Things started looking good. Then the machine sputtered. We got no real good, solid Kelvin wave production or westerly wind events after that, and our El Nino just really never materialized. We're thinking the atmosphere is more prime now that La Nina has been totally kicked out, and supposedly the PDO, the Pacific Decadal Oscillation, is switching in favor of El Nino development. So we'll have to see what happens. And here's yet another way to view the data. This is the West Pacific. This is the East Pacific. This is upper ocean heat anomalies, 300 meters and above. So basically, last year you can see the big Kelvin wave working its way east into the June time frame even. Then we have the upwelling Kelvin wave phase, cooler water. And then here's what happened in August, September, October. We got Kelvin waves, but they were just very weak, not well formed. Yes, it did propagate warm water to the east, but just not enough to really hype up El Nino, because El Nino peaks out typically in the December time frame, and there just wasn't a good source of warm water to keep feeding the cycle. Now here we go again. This year, 2015, the new Kelvin wave developing, looking very solid indeed. So it's going to make its way across. The question is, what's going to happen in like the June, July time frame? Will we get a strong Kelvin wave, or will the atmosphere again sputter? Unknown. But here's a teaser. This from the CFS version 2 model forecast for Nino 3.4 region. That's the main area for sensing El Nino. This model has recently skyrocketed. That is, water temperatures currently in the 0.8 degrees, let's say. But notice, by July, temperatures are forecast up to 1.6 degrees above normal. By October, up to about 2.2 degrees above normal, pushing about 2.3 degrees in November, December time frame. If this were to occur, that would be a significant El Nino on par with the 97-98 El Nino. Now, let's put a little water on the hype here. The model did the exact same thing last year, suggested this exact same scenario, and it never materialized. So who knows? And if you go look at a whole bunch of other models and compare them, they're all over the place, but they basically suggest a continuation of this what we call Modoki El Nino. El Nino, but not really. That is, water temperatures hanging out, let's say, around 1 degree or so, half a degree to 1 degree into the fall. So it's anybody's guess what's really going on. This model is the highest of all of them. There's 10 or 15 other models out there. They all are all over the place. Nobody knows. We're in the spring unpredictability barrier. Typically, that runs from about the March time frame to middle of May or so, where just none of the models can really get a handle on what's going on. The atmosphere is in a state of transition, and historically, it's hard to make a good forecast. It's not till you get to June before you can really say whether we're going to go into El Nino or not, and even that might be a bit on the early side. But for now, things are certainly moving in the right direction. That is, all the signs are in favor of El Nino, and there's no sign whatsoever of La Nina in play. So for now, the North Pacific is pretty much asleep, not a whole lot going on. The South Pacific is trying to come online. The models are teasing it may be something developing, but it's still very early in the season. It's barely April at that. The traditional season for things waking up is more mid to late April. So we're actually doing on track. We've had some decent southern hemi swells already, so we'll see what happens. In the meantime, La Nina, not in the cards anywhere. El Nino appears to be trying to organize. We'll see whether it really happens. We've got a good Kelvin wave in flight. We'll see whether something better comes in the June time frame. So for now, things are moving in the right direction. Best option now, go get some waves, get whatever you can. We're in the wind swell season. Just go make the most of it, and let's keep our fingers crossed long term. We'll do this again next week, same time, same channel. See you then. Thanks for watching.